In this lesson, we shall be looking at Bernoulli equation. Under differential equation, when we see a differential equation is Bernoulli, then first it must be a first order differential equation. So let's take note of that. Every Bernoulli equation is a first order differential equation. It is of the form y prime is equal to q of x y plus p of x y to some power n. Whenever you see an equation in this form, it is called a Bernoulli equation. But let's take note that n should not be equal to 1 and n should not be equal to 0, because if n is equal to 1, then it ceases to be nonlinear. Bernoulli equation is nonlinear. Let's take note of that. It's nonlinear first order differential equation. It's nonlinear and it is also a first order. For it to be nonlinear, n should be greater than 1. That is the condition. It shouldn't be equal to 0 and it shouldn't be 1. It should be greater than 1. Now, if n is also equal to 2, it is still a Bernoulli equation. But this type of equation is called logistic equation. It's called logistic equation. We shall look at this in our later discussion. So for now, let's take note that for every Bernoulli equation, n shouldn't be 1 and n shouldn't be 0. Alright, so it means that anytime if I have the Bernoulli equation y prime is equal to q of x y plus p of x y n, if I divide through by y of n, I'll get y prime of yn should be equal to, then if I divide here, it becomes qx of 1 over, so that is going to be y n minus 1, because this y will go down, and when applying the laws of indices, it becomes y n minus 1, then plus, here becomes p of x. So that is it. So this question here is a Bernoulli equation. So I can simplify this equation as y prime divided by y to the power 5. The n is 5 here. So should be equal to y divided by y 5 minus 1. Let me use this one. We are dividing all by 5, then plus 2y of 5 divided by y of 5. So when we do this, we will get y prime over y exponent 5 should be equal to, here becomes 1 over y 5 minus 1. That is what we have here. And that will give us y exponent 4 plus 2. Now, remember the Bernoulli equation is nonlinear. But to be able to solve it, we need to find a way to convert this nonlinear differential equation to a linear differential equation. So always the coefficient of the q of x, so in this case it's going to be 1 over y exponent 4. You will let that becomes your u. So I can say that let u be equal to 1 over y exponent 4. So we can make a headway. From here, we can do some substitution. What you have to do is to differentiate this and also differentiate this. We are differentiating both sides with respect to t. So differentiate with respect to t, with respect to t. So we are differentiating with respect to t. So in that case, if I differentiate u with respect to t, I'll get 1u prime. So I'll get u prime here should be equal to, if I also differentiate 1 over y exponent 4 with respect to t, the first thing is to differentiate this. When I differentiate this, I'll get negative 4 over y exponent 5. Then I have to multiply this by y prime. So I'll be getting u prime is equal to negative 4 y prime divided by y exponent 5. Then from here, you could see that I have y prime over y exponent 5 here. So let us divide through by negative 4. If I do that, I'll get 4u prime over negative 4 should be equal to y prime over y exponent 5. So now I can substitute this into this. So let us do that. So by substitution, y prime over y exponent 5 is negative u prime over 4. Then should be equal to y over, we are here. So should be equal to 1 over y exponent 4. Remember we said u is equal to 1 over y exponent 4. So that is u. Then plus 2. Now let us simplify this. To simplify this one, I'm going to get negative u prime should be equal to 4u, then plus 8. I'm just multiplying through by 4. Then I can group like terms. If I group like terms, I'll get u prime plus 4u should be equal to negative 8. Should be equal to negative 8. Now if you look at this differential equation is now a first order and it is linear ordinary differential equation. So we can solve this one easily by first finding the integrating factor. So from here we can see that our integrating factor is going to be the integral of 4 dt. Then by solving this one, we will get to the power 4t as my integrating factor. The next thing is to multiply through by this linear differential equation. So by doing so, I'll get E40 multiplied by the U prime plus here 2 becomes 4 E40 multiplied by U, then should be equal to, here becomes negative 8 E40. Alright, so that is the concept here. So when we get to this point, we know that anytime you multiply through by the integrating factor, the left hand side will be simplified as our integrating factor E40 multiplied by the dependent variable here, which is U. Then all prime should be equal to the right hand side, which is negative 8 E40. Then from here we can find the total derivative of this by integration. So you integrate with respect to t. When you do that, here becomes E40U. Then should be equal to, the integral will cancel the derivative. So we have E40U should be equal to, if I integrate this one, I'm going to get negative 8 divided by 4, which will give me negative 4. That will give me negative 2. Then E40 plus your constant of integration. Now let us take a total derivative of it. So we have E40U plus 2E40. All this should be equal to the constant C. But if I take a total derivative, then it will be equal to 0. This means that this is the total derivative, and our potential function is this. What is inside? So I can say that my potential function, when differentiated, the potential function is t, y of t. When you differentiate this, you will get 0. But if I don't differentiate the potential function, then it is equal to a constant c. And that constant is what is inside the bracket here. So I can say that E40U plus 2E40 should be equal to the constant C. Now we can solve for U by first dividing through by E40. If I do that, I'll get U plus 2. U plus 2 should be equal to, if I divide here by E40, I'll get C E negative 40. So that is it. Then finally, my U of t will be given as C E negative 40 minus 2. So that is the solution in terms of U. But take note that the original question has no u. We made u to be equal to 1 over y exponent 4. So we are going to substitute that back. So to substitute that back, then we can say that our u here is 1 over y exponent 4 should be equal to c e to the power negative 4t minus 2. When we get to this point, we can reciprocate. When you reciprocate, you get y exponent 4 should be equal to 1 over c e to the power negative 4t minus 2. Then we can find y by taking the fourth root. So we can say that y of t should be equal to the fourth root of 1 over c e to the power negative 4t minus 2. But the fourth root of 1 is still 1. So we have y of t to be equal to 1 all over the fourth root of c e negative 4t minus 2. And that is the solution. If you like, you can write it this way: y of t is equal to 1 all over the fourth root of c over e 4t minus 2. This is also correct.